So we've talked about the kind of connectivity on an anatomical level that's needed to support semantic memory. Now let's look at things at an even more detailed level and look at the way neurons have to operate in order to support the phenomenon. Visual columns must be activated both by inputs derived from earlier visual areas and by inputs indicating the appropriateness of activation on the basis of past simultaneous activity. But activation of a column means that neurons within the column must be activated. The problem is that a neuron must therefore get inputs from earlier visual areas and determine if its receptive field is present in those inputs, but also input from higher areas, and it must determine if it has enough of those inputs to justify producing output. So effectively it must also support a receptive field that determines when it will be indirectly activated. But that presents a problem. If inputs indicating direct and indirect activation are mixed together and integrated as a whole, sometimes the neuron will be activated with only half of one receptive field and half of the other is present. In other words, when activation is inappropriate. So, direct and indirect inputs must be segregated and integrated separately. The way the brain does this is that axons derived from neurons in previous visual areas pass through the layer in which the basal dendrites are located. Synapses are made onto the basal dendrites from those axons. Axons from higher areas pass through the region where the apical dendrites are located, and synapses are made from those axons onto the apical dendrite. So neurons effectively have two, and they could have more, receptive fields that are detected in different circumstances. At an even more detailed level, the receptive fields in the intermediate area that correspond with groups of columns often active at the same time can be defined by the same dendritic branch and synaptic mechanisms as those described earlier for direct sensory fields, because they use the same type of temporal correlation information. And at even deeper levels of description, within the synapse, the descriptions are much the same as we've covered earlier.